Well, as I was saying, I've been fortunate enough to actually work with Rio Grande silvery minnow for, I don't know, I'd say 7-ish years, and working with Grace Haggerty and the New Mexico Interstate Stream Commission, kind of developing and working on, the evolution of their monitoring program for silvery minnow to look at all these restoration sites and, are they providing habitat for this endangered species? So it's been pretty exciting to watch, these sites change over the different years that I've been here. So, and I started at SWCA in 2017. So let's just get going here. Habitat restoration in the middle of Rio Grande. So the role of the New Mexico Interstate Stream Commission. There we go. I guess a lot of this, some of these slides, these background slides will be, very similar to Andrea's great presentation, talking about a little bit of the history here and how, our extensive water use has changed the Rio Grande, and we, for our desire of like controlling floods and, managing water, right? I mean, this is not unique to us. This happens all over the place, right? All over the world. So, between 1930 and 1950, you can see like hundreds of miles of levees were created, and we took what we had on the left side here, this big wide river with a big floodplain, to something you see on the right side, delinking the floodplain, so losing that floodplain connectivity. As Andrea was talking about, these jetty jacks, right? And you're right, 100,000 plus right there. So, yeah, there's been a lot of these jetty jacks, and if you've been out on the river, hopefully you haven't run into it on your inflatable kayak or run into it with your leg, because that's just not very fun. But a lot of these were installed to trap sediment and stabilize banks, and what do we get from that? We get channel narrowing and down-cutting, and more of that floodplain disconnection, right? So I thought this was a pretty interesting metric here. Approximately 82% decrease in maximum channel width from 1918 to 2001. I think that's pretty crazy. So I guess this is a little bit of the regulatory background from the biological opinion, just essentially talking about and identifying habitat restoration as a key action that need to happen for recovery of species. So, habitat restoration began in 2003 with a 2003 BO. There's been 10 program partners and a lot of sites, over 300, and lots more to come. So, pretty interesting. They're designed to inundate at different discharges, right, from 500 to 3,500 CFS. A lot of the ones here in the in Albuquerque area were designed to inundate around 1,500 CFS, and so it's been pretty cool to watch that since 2017. I guess 2016 was when the New Mexico Interstate Stream Commission and SWCA really bumped up their level of effort on collecting a bunch of habitat data in regards to these restoration sites and silvery minnow. So here you go, and here's some various inundation of some of the restoration sites. There's a Corrales, the PDN, Paseo del Norte, Southwest and Southeast sites, which are water authority sites, Tingley, and so 2016, yeah, 2016 was a pretty good year. 2017 was the first year I started, and on Tingley in 2017, when the first day we started monitoring with fikes for adults, I think we were out there till like almost midnight looking at fish. So, I mean, we caught a lot of fish that year. So it was pretty exciting to see all these silvery minnow come up on floodplains and use this habitat, and then further develop a monitoring plan for them. So looking at, like describing larval habitat was one of the big things that we focused on with the New Mexico Interstate Stream Commission in the following years from 2017 onto current. So here's some more pictures of some restoration sites and inundation. Like I said, we use fike nets as a method to capture adults and larger fish that are either coming onto floodplains or leaving floodplains. And it's been a pretty effective method. They've used it even previously with people like Eric Gonzalez, who's now at the Bureau of Reclamation, and Mike Hatch, and a lot of other people. So it's been pretty exciting to do this monitoring here. So we are providing, I guess, 9 significant findings here. And I'll go through these here slide by slide, but it's been, let's see, since I think this is incorporating everything from 2016 on, and we see that there's a large amount of, most of the Middle Rio Grande fish species use this habitat, right? So 55% have been captured on floodplains during floodplain inundation on the years we get floodplain inundation, of course, so which is not every year, but and it's pretty interesting. Silvery minnow make up a large portion of that in years where we get floodplain inundation. Silvery minnow move on to these sites during spring runoff, right? So we typically see a bump in the hydrograph somewhere around April, and then May is when it really kicks off, and that's when we see that big pulse of silvery minnow adults, gravid and nuptial adults moving onto floodplains. And so some of the previous work that was done by Eric Gonzalez and Mike Hatch, capturing eggs on floodplains and describing reproductive readiness of adults on these floodplains. So getting, adults to either express eggs or milt. So that's become one of our, common things that we look for every year when we get floodplain inundation during spring monitoring. And here's just some numbers from previous studies from Gonzalez here. We see that we had in 2008 108 females expressing eggs, and so just kind of building that story of floodplain habitat as being very important for spawning and nursery habitat as well. So for looking at this very large picture of what is happening during the spawning period for silvery minnow. One of the things that we still kind of look at and still trying to wrap our heads around is residence time on floodplains. So we can get to that somewhat by looking at the distribution of larval phases, so larval developmental phases on floodplains from our dip net sampling. And we also can look at it, and we don't have, I don't have a figure of this, but I can't remember what year it was, maybe 2019, but we actually had a pit tag antenna out in one of our restoration sites down in the Santa Acacia Reach, looking at the cumulative number of unique detections over time at one of the restoration sites, which was really amazing to see as the hydrograph went up, that we saw more fish coming in and then leaving. And it was this beautiful bell-shaped curve, and I'm sure we probably provided that in a previous presentation, but if you are interested in seeing it, I can always find it somewhere and and share it. So another finding is runoff and hatch time should occur synchronously, right? So here we're talking about the hatch dates. So with the ISC and the Water Authority, we did some otolith work and aged larval fish. And well, prior to that, we did the validation study and then aged wild fish, and looked at this to be able to back calculate hatch dates of the larval fish that were captured in our restoration sites. And it's pretty impressive, when you look at it, in this way. Sure, we know that these are spring runoff, spring pulse, fish, right? They're getting up on the floodplains during this time. But this is just a really great way to actually visualize and look at these hatch dates and how they match up with peaks in flow. As you can see in 2016, that large pulse in May when you see like all the hatching occurring, and then you see it in 2017 as well. So that's been a really interesting and, I don't know, very important thing that we've done with the ISC on looking at, back calculation of hatch dates from otolith work and stuff like that. So again, based on our larval catch data and having, so IDing all the larvae because you can't ID them in the field, and classifying what larval developmental phase they are, we can look at the distribution of all these different larval phases in different areas. So you can see on these figures on the right, 2016, 2017, on the floodplains, we see all the different larval developmental phases present with very few juveniles. And where we see the juveniles are when we sampled in 2017, we did floodplains and we did main stem sampling. And we see a lot of the juveniles were captured along the main stem. And that's kind of along the lines of thinking that, Rio Grande silvery minnow larvae residence time on floodplains is like somewhere in that 30 to 40 day period where they've grown to a point where they've developed all their fins and they're highly mobile, and so they can move out of these floodplains into other areas of the river. And as I said previously, silvery minnow, especially in these years where we have floodplain inundation, are the most abundant fish species. So, a lot of the habitat data that we've looked at and measured over the years with ISC since really 2017, we were able to, kind of pare down a good description of nursery habitat. Yes, we know that nursery habitat for larval fish can be like, these warm waters that are shallow, and low velocity, but putting some numbers behind it is really important. So since 2017, we've measured all these different things like water temperature and depth and proximity, like to land, right? So they're usually found near some shoreline habitat and found in warm and shallow waters with low velocity, and then associated with the bathtub ring concept of essentially food availability in these areas. And I guess that was the last slide. So that seemed abrupt, but sorry. Yes, can I answer any questions? And if I can't, we can always ask Rich.